All right, good morning, everyone. Welcome to this week's episode of Pulumi TV. My name is Luke Hoban. Today I'm here to talk about some of what's new with Pulumi for Kubernetes. So last week we released Pulumi 0.15, which is the latest release of the Pulumi toolchain and libraries and frameworks. And one of the major features of this release was new support for Kubernetes and improvements across a lot of the existing support for Kubernetes. So to put that in context, Pulumi really lets you sort of manage all kinds of resources in the cloud. So everything from resources inside your cloud provider, inside AWS and Azure and GCP, as well as resources that are deployed via Kubernetes, whether that's on-premise or in one of those cloud providers. And so with the support for Kubernetes, as well as the support for OpenStack that we released with 0.15, you now can sort of take your entire kind of cloud application and manage and deploy those resources with Pulumi. So today I'm going to really dive a little bit deeper into kind of just using Pulumi directly for working with Kubernetes resources. And what Pulumi brings is really the ability to kind of structure the way you think about deployments to Kubernetes in a bit more formal way. And that's from a few different kind of perspectives. One, you get to sort of describe the dependencies between components that you're deploying to Kubernetes and make sure that you stage those rollouts of different components in an intentional way. Instead of just kube control -f to push some YAML up to Kubernetes, here we can describe and orchestrate sort of interesting and more complex deployments and make those be able to make one change and then wait for that change to have been applied so that we are in a stable state and then make another change. So we'll see how we can use Pulumi to describe that sort of thing. Additionally, Pulumi, of course, lets you use programming languages, so software, to write your applications and your deployments instead of just using YAML. And so even though we still are using a declarative kind of technique where you're describing the goal state of your infrastructure, the ability to use code lets you sort of describe reusable components, create abstractions, give names to things, document things better. And so we'll see a bunch of the ways in which being able to use a real programming language, in this case we'll use JavaScript and TypeScript, gives us a bunch of sort of ability to structure our code in sort of more formal ways and benefit from kind of software engineering practices. And finally, the ability to sort of combine Pulumi's support for Kubernetes with Pulumi's support for AWS and Azure and GCP means you can build applications that span both. And we've seen when we talk to users and customers of Kubernetes, they're frequently also users of other cloud platforms. And so they want to build applications that span both, that store objects in S3 or that use a managed database in RDS, for example, but run their compute within Kubernetes. And so this ability to build applications that span both public cloud infrastructure and Kubernetes for compute is one of the really unique things that Pulumi provides. So with that, let's just see a few kind of concrete examples of what it looks like to use Pulumi with Kubernetes. So I'll come over to Visual Studio Code and we'll look at just a simple example here. So let me go into this folder. First off, I should note I'm in our examples repository here. So this is github.com/pulumi/examples. And we have quite a lot of examples overall. So we have examples for using AWS, for Azure, for our cloud library, which is sort of a high-level library that crosses the different clouds, for GCP and for Kubernetes. And as part of the release last week, we actually added 3 new examples of Kubernetes to highlight a few more different ways you can apply Pulumi to Kubernetes application development. And so I'm going to walk through each of those examples today, kind of show off some of the interesting things that those examples highlight. So the first one I'm going to do is go look at the Kubernetes TS Guestbook example. And so let me just go into that folder here. And for those who aren't familiar with this, the Guestbook example is sort of one of the canonical examples that Kubernetes has had in their tutorials ever since it was first released publicly. And it walks through deploying a simple application. In this case, it's actually a PHP application that's a Dockerized application and is being deployed with some Redis master and slave instances, as well as a Kubernetes deployment that scales out a number of pods to run the front-end HTTP service, as well as a service to actually provide access to that. And so if you go into the Kubernetes documentation, you see lots of material where they cover kind of walking through doing this using the Kubernetes YAML. And you can see, there's quite a lot of YAML, even for this fairly simple app. It's, there's a lot of details you kind of have to fill out and to apply using kube control apply-f. And so it's a bit involved, even just to kind of stand up this example, but it's a good example to go through to get a sense of kind of Kubernetes basics. So in this case, we actually went and took that example and ported it and are showing what it looks like in Pulumi. And so I'll walk through a few of the sort of most salient points in this code, and then we'll see kind of what the workflow looks like to actually work with it. So the first thing is we're using the Pulumi Kubernetes library. And so this library is how we get access to all the Kubernetes support. And this library actually provides access to everything that's available in Kubernetes. So every kind of resource that is available within Kubernetes is projected and usable from this library. And so I can come in here and say something like, let x equals new k8s dot, and you see I get access to everything that's within this library. So apps v1, I can get replica sets, daemon sets, stateful sets, all of the capabilities, including bleeding edge things that are only recently added into the Kubernetes API surface area. And this will actually, based on the cluster that I'm connected to, this will actually connect to that and make sure that the API is supported. And then if it's not supported, we'll actually give you early errors saying that capability is not supported in your cluster. And so you can access through the API everything that's available in Kubernetes, and that will correctly work or error in a useful way if you're running in a cluster that doesn't yet support that capability. So even just getting that IntelliSense there is actually pretty handy. One of the nice benefits of being inside a programming language is we can sort of get that k8s dot. This kind of ability to explore the API surface area is something that's really nice when we're kind of using a tool like Visual Studio Code and a language like JavaScript or TypeScript here. But let's go see what it looks like to actually use that. So the second thing you'll see is that we actually have a local file ./util where we have some of the utilities. And so I can click on that. And we see that this is a way to sort of break up our code into multiple files to sort of factor it in the same way we might some sort of application code where we factor out a helper function here which deploys sort of a particular pattern. In this case, it's returning a deployment. But it's creating a deployment with a particular kind of pattern, a particular way of applying a name as the set of labels for both the selector and the labels to apply on the actual spec itself. And so in this case, and also in this case, just to deploy a single container. And so this just provides a really simple API surface area to a common pattern that we might want to use throughout this application. And now if we want to make changes to this, we can do it in one place and have those be applied everywhere. And we could do this without having to just do sort of templating or that sort of thing where we just match up strings or whatever. Here it is actually software. We're getting type checking. We're getting completion lists. We're able to document this with a comment. All the things we'd sort of expect from kind of a software engineering thing. And we'll see how we use that utility in just a second. The next thing is Pulumi has a notion of configuration, and so I can actually provide external configuration to one of these Pulumi programs before deploying it. And so in this case, we've parameterized it by a configuration parameter is Minikube, and this will decide whether or not we deploy it using cluster IP or a load balancer, just because load balancers are not currently supported in Minikube. And so this allows us to sort of parameterize the way that our application can be deployed and allow users of the application or people who are going to stand up this same code base to deploy multiple instances of it with different kind of parameterizations. And so let me come down, and before I actually walk through the individual pieces of code, let's see what it looks like to actually use this. So I can say Pulumi stack init, and I'm just going to say guestbook. Actually, first off, let me just show you one other thing. For these examples, I'm actually going to run them against GKE. And so you can see I actually have a handful of contexts in my kube control. So it's wrapping a little bit, but you see I have Docker for desktop, I have Minikube, I have an AKS Azure Container Service cluster, and then I have a couple of GKE clusters as well. And so we can support any of these with the Pulumi Kubernetes support. But today I'm going to use GKE. GKE has very nice Kubernetes support generally, and so I'm going to use that for some of the demos here. And so whatever I've picked as my current context on kube control will be the default that we'll attach to with the Pulumi Kubernetes provider. You can, of course, override that. You can provide your own kube config. You can provide your own context to pick as part of configuration. of the application. But by default, we'll just kind of do the right thing and pick up the ambient context that's been provided. So with that, I'm going to say Pulumi stack init, and Pulumi stack init lets me create a new instance of this application. And so in this case, I'm going to say Pulumi stack init Luke guestbook GKE. Okay, so now I've got that, and now I'm going to say Pulumi update. And this will go and try and apply all of the changes described in this Pulumi application into my target environment. And we should see this will actually give me an error. And it'll tell me that the guestbook is minikube configuration parameter is required. And that's because we said this configuration parameter is required, and so the application can't be deployed without providing a setting for this. So I can come in here and say Pulumi config set. Let me just grab that. And I'll say false, because we're going to run this in GKE. So let me now say Pulumi update. This will actually go and show me what it's going to need to change to deploy this application. Now, the way that Pulumi works, we by default always show a preview of what changes we're going to make to your target environment before we go ahead and actually deploy those. And this is a really nice way to understand what implication there is to the action you're about to take on your target environment. In this case, we see we're going to deploy 6 things. 3 deployments, a front end, and then the Redis master and slave associated with that, and a service front end and the services to support those 2 Redis capabilities. If I say details, I get to see the full details of what this is going to deploy, and this looks a lot like the Kubernetes JSON or YAML that you might see if you were deploying this. I'm going to go ahead and say yes and let that proceed. And while it does, I'll show you what some of the code here looks like. So we see that we use that util.deploy container to deploy a simple container with just the parameterization we care about: the name, the image it's going to specify, the resource requests, and the ports that need to be exposed. We can then describe the services using Kubernetes Core v1 service. Again, really the only text here is kind of the stuff that is really required for this particular application to be stood up. We'll do the same thing for the Redis slaves and roughly the same thing for the front end. The biggest difference for the front end is, of course, we're actually able to write sort of custom code here to say if it's minikube, then cluster IP, else load balancer. And so this ability to write arbitrary code, we could have this be arbitrary logic that reads something from disk, that makes a network request, anything we might want. We can do that just in line as part of constructing the JSON or YAML kind of specifications for these components of the service. And so this is a really nice and kind of natural way to do that once you're working within a programming language like JavaScript here. And then finally, we're going to expose sort of the key piece of information related to this deployment, which is what is the IP address of this service that's running now inside my target Kubernetes cluster. And in fact, here again, we're going to switch on whether this was minikube or not, because if it was minikube, we'll get that cluster IP. If it wasn't, then we'll get the load balancer and find its ingress IP address. And so we see when we actually ran that, it took just, what did it take? 52 seconds to kind of do that deployment. And it created the deployments and then created the services. We got some information about, the IP address being allocated for the front end and about the endpoints being created for all of those. So we got some useful kind of status during that deployment about what state each of these resources was in as it was being deployed into my Kubernetes cluster. But ultimately, the most useful thing is that I got this front-end IP address. And so I can do something like, open http:// and I'll just do Pulumi stack output front-end IP. Oops, that's not going to work. Okay, so there we go. Now we've got a guestbook application running. And I'll just say hello from Pulumi. All right, not sure why that didn't work, but we have a guestbook application running. Try it one more time. All right, not sure what's going on inside the GKE cluster there, but we will come back and look at that after we've looked at some of the other examples as well. Now, one thing to notice, this deployment is actually tracked inside the Pulumi console as well, and so we see that this stack that we stood up, I can come to app.pulumi.com and see the information about that stack. So I can see that configuration I provided, I can see that output, I can see all the different updates I've done to this stack, and I can see all the different resources as well that are available within this stack, including a nice graphical view. So that's a quick look at what I can do to build one of these. So now the other interesting thing I might want to do here is say, Pulumi config set, and I want to say is mini. Let me see what my config is. So I listed my config, and that's set default. But imagine I want to change this to true. I'll take a look at that. So now I've changed that to true. And now if I run Pulumi update, we'll see something different. We'll actually see kind of a diff of what's going to change. And in this case, the only thing that change impacted was the value for the service. But because this is changing this service from a cluster IP base or from a load balancer to a cluster IP based service, that's a change that Kubernetes actually does not allow to be made to an existing resource. So it would reject that change if we tried to make that change in place. Instead, we would have to make this change, we have to replace that resource. So we have to create a new service that is of type cluster IP and then delete the old service. And so if we want to go ahead and do this, Pulumi will let us know that we're about to replace this thing. And that's going to be a destructive change because it's actually going to change the externally visible IP address. And so we will see this. We'll say, OK, we want to make that change at this point. We're going to say yes. And this will go ahead and do a few things. First, create the replacement. So let's make sure that the new thing is stood up before we tear down the old thing. And that will stand up the service with a cluster IP. And then as soon as that's done and we verify that that worked correctly, then we'll tear it down. And you'll see the front-end IP is now different because this is now the cluster IP-based front-end IP. And then if I can remember how to do this, kube control port forward, service slash, and what was this service? There we go. Does that work? The way around. Okay, so now we're port forwarding to that service on port 8081 on our machine, port 80 inside the cluster. And so let's see what we have running at 8081 now. So here we have that guestbook running on that proxied service against that cluster IP. We don't have a load balancer exposed on the GKE cluster, but we can still access it using that new IP address. So a couple things there. One, the ability to easily sort of configure these kind of applications and have those configurations via code actually lead to interesting changes to the deployed infrastructure. But then those interesting changes being described and being explained through the Pulumi CLI in terms of the specific implications they're going to have on your infrastructure, so that can be audited, reviewed, and verified before actually doing the deployment. Okay, so that's a simple example. I can then come and say Pulumi destroy if I want to tear this thing down. That'll tell me it's going to delete all of these resources. I say yes. And it'll deploy each of the services and then each of the deployments as well. So I'll just give that a second to complete. While that's going, let's go over and find one of the new applications that we want to take a look at. So let's next look at this config map rollout example. All right, so in this example, there's a couple of interesting things we kind of want to highlight. So this example is really about how do we orchestrate changes to an existing application. And so one example that we've seen some folks who talk to bring up that's a pain point for some folks in using Kubernetes and kube control and trying to coordinate deployments is when I have a change to a config map and I want to actually cause that to roll over a service that depends on, or a deployment that depends on that config map. And so in this example here, what we're going to do is post a nginx config file. So let me open that up as well just to give you a sense. So we have a default config for nginx, which is just going to forward me to pulumi.github.io. And I'm going to store this in a config map, and then I'm going to create a deployment which actually mounts that config map. And so this is all just fairly standard Kubernetes. And then I'm going to expose a service that, similar to the previous example, just as a front end to that particular deployment. So what we're going to do is first we'll stand this up, show just that we can bring this application up as you'd expect, and then we'll see what happens when we try and change that config map and how we can coordinate the deployment of that config map and the implications it has on the change to our Kubernetes deployment object. So let's take a look at that. We're going to come over here and go to Kubernetes TS config map rollout. And again, I'm going to Pulumi stack init config map Luke GKE. And then I'll say Pulumi update. And again, I need to set this config variable. So let's do Pulumi config set and false. Okay, so now let's do Pulumi update. And this will, just like before, show me the things it's going to create. In this case, it's a little bit simpler. It's just that config map, that deployment, and that service. And so I'll go ahead and say yes. And we'll deploy these out into our target Kubernetes cluster. Now, one other thing that I'll note just briefly here is we actually, to get that, that default.conf, we actually just used Node.js fs.read file sync. And this is sort of handy. This just shows us that we can do whatever we want to, from a code perspective. Because we have access to a Node.js runtime to do this deployment, we can just read a file off of disk, or we could have retrieved this from a network share. We could have gone and used some secrets management system that we have credentials for only on our deployment environment to go and read that out of our parameter store or whatever we were using inside our cloud service to store these secrets. Anything we want to do to construct the inputs to a program, we can do programmatically here, but that'll still be used as input to define a declarative desired state. And then, as we saw, we'll preview what implications that has for the changes to the application. And so even if that file changed on disk, we'll still show a preview of here's what changes are going to need to happen as a result of that. And so here I now have this, and so I can say curl, I need to do -L to follow redirects. And so here we see we're actually hitting Pulumi.com. This is the title for the Pulumi.com webpage. And so our Nginx server that's forwarding, reverse proxying to Pulumi.com is deployed and working inside GKE with that load balancer deployed using this Kubernetes application. So what we want to do now is just change that config map. And so maybe I come over here and I will say www.google.com. Okay, so I'm just going to save that on disk and come over here and say Pulumi update. And like we talked about, because I was using that sort of fs.read file in Node, the input from this file is now actually part of my specification of my desired state. And so just by changing that on disk, it actually changes what my application is saying its ultimate desired state is. And so we'll see that Pulumi tells me what it thinks it needs to do to achieve this new desired state of this newly forwarded address. And there's two things here. The first is that config map needs to get replaced. We need to create a new config map inside our Kubernetes cluster with the new information. And then we need to update our deployment to point at that new config map. And then ultimately we'll tear down the old config map because it's no longer being used. And so I can again come in here and look at the details. We can see the exact details of what's going to change. So for example, we see that pulumi.github.io changing to google.com. And we see the deployment changing its config map name from this one to this one. And so we can look at all the details and make sure we're really comfortable with that change before saying yes. And again, just like we saw before, this will create a replacement, say it replaced it, and then update the deployment with those changes, and finally delete the original. So it happened very quickly, but all those steps actually happened in order. And so now if I go and hit that same URL, we should see I get different content back. Maybe google.com doesn't return correctly. Well, we definitely get different content back. It looks like it's an error 404 not found. Maybe we have to go to www.google.com. Just for fun, I'll do an update and see if that works. Nope. Not sure why it's not liking the upstream of that site, but regardless, we'll see that we got different content, so the rollout did work correctly there. Okay. So that's an example of just kind of how we coordinate these things. And this is where I think Pulumi in general comes in very, very handy. Pulumi fundamentally understands the dependencies between different resources in my application. And so this, if I come back over here to the code I was looking at, in this code, we see that this config map here, Nginx config, is a resource, and then I get the config map name by grabbing the metadata's name property, and then I use this config map name as the input to the volume here. And so by doing this, by passing an output of the config map as an input to Nginx, instead of just having two strings which might happen to match, I actually am declaring to Pulumi that there's a dependency between these things. And so it should make sure that whenever this changes, it make the appropriate changes to the Nginx resource here, or the deployment resource. And this is the core of sort of Pulumi's planning engine, is its ability to understand dependencies and understand when changes to one resource imply that another resource needs to be updated in place or itself replaced. This dependency information can also be provided explicitly, so I can provide depends on, and if I want to explicitly say I depend on that thing and not just rely on the implicit dependencies via these parameters being passed through, I can do that as well. But by default, I get very explicit sort of dependency information being captured just by the core structure of my code. And this is something that when we do application development targeting sort of the major cloud providers is really critical, because they have much more structured sort of dependency information where to create some certain resource, I have to have previously created several others. In Kubernetes, this is less true. There are many resources where I can stand up both a deployment and a service and wait for, they'll just sort of internally kind of keep cycling until the other one is ready. But there are many cases where I actually do intentionally want to cause certain updates to happen because a dependent resource is changing. And oftentimes those things are pretty difficult to coordinate using Kubernetes, and so folks end up having to kind of invent a bunch of scripting outside of Kubernetes itself to coordinate certain kinds of release processes. And this is the sort of thing we really want to make just a simple part of the authoring process for deployments by using Pulumi. So this example, again, just exposes kind of this is Minikube and the ability to factor over these things. So before we go, let's look at just one last example here, and that is this Helm WordPress example. So in the previous two examples, sort of one of the salient characteristics of them was that we kind of wrote all of the Kubernetes resources inside a Pulumi program. And so that meant that if we had existing YAML files or we had existing Helm templates, we were talking about sort of rewriting those things inside Pulumi. And doing that does provide many benefits, like the ability we saw in the last example to actually declare and understand dependencies and track those and do coordinated rollouts. And obviously the authoring benefits of just writing this stuff in software and being able to abstract over things. But obviously, folks using Kubernetes have lots of existing Kubernetes artifacts, either defined using existing YAML files or using existing Helm charts. And so using the Pulumi Kubernetes support, we actually also have the ability to import either Helm charts or Kubernetes YAML files. And this allows you to take existing assets as is and just incorporate them into a Pulumi program and take advantage of Pulumi for sort of coordinating the deployment of those assets and for potentially marrying that with the deployment to AWS and Azure inside the same program. And so in this example, we're just going to deploy WordPress. And so we're going to use the Helm chart. We're going to use the stable repository that Helm manages. We're going to specify the version of that we want and the chart name inside the stable repository, which is WordPress. We're going to then grab, we know that inside that WordPress Helm chart, several resources get created. And one of them is a v1 service whose name is wp-dev-WordPress. And so we'll go and grab that resource out, and then we'll read some properties off of that to expose what the front-end IP address is for this. So let's take a look at that here as well, Helm WordPress. And like before, I'll just say Pulumi stack init, WordPress, GKE, Luke, Helm. And I'll just say Pulumi update. And I suspect, just like before, we'll need to specify this is Minikube thing. I should note this is Minikube thing is something that we've done in these examples. You can, of course, in your own applications, provide whatever configuration you want, and you don't have to provide this kind of is Minikube configuration setting. And if your deployments tend to be all to a particular environment that you know does support some things, you can make these optional configuration that's defaulted to the right defaults for your environment. For these examples, we chose to make these required config to make sure that folks have a good experience and don't have things fail unexpectedly because they're running in one of Minikube or an environment that does support load balancers. And so again, I'll set this to false. And now we'll run that Pulumi update one more time. So this is going to create 13 resources, so a fair few more. One of the key things we'll notice here that's different is we're actually creating a component. And so Pulumi has this notion of components, which are resources that you can create, in this case, this one here, that themselves don't manage any particular resource in an external cloud environment or Kubernetes cluster, but virtually manage a variety of other resources. And so in this case, this chart manages a bunch of other Pulumi resources, each of which is a specific resource tracked in an external provider, in this case in the Kubernetes cluster. And so we'll see that we actually get those nested underneath each other. And so each chart that we deploy will actually be a different node in this graph, and we'll be able to see all the different components that we've deployed, as well as all the individual details of those components. So I'll go ahead and say yes. The key thing here is that we actually just extracted all this information out of that Helm chart. And so we actually did all the same things that Helm does. Go and grab that chart, template it out using the Helm templating system, and then create the YAML files that Kubernetes expects, and then read those YAML files in and populate a set of Pulumi objects to represent what we want to deploy out into Kubernetes. And so just like before, we see all this deployment and we see the progress as this is happening. The ability to get an insight into what's happening during our deployment is a key thing here. We can see which pieces are already created. We can see that this service is actually still creating. That needs to allocate a load balancer, so it takes a little bit longer. And we see that the deployment of WordPress itself is still creating. That's the actual deploying the pods and making sure that that is healthy, which requires pulling down that Docker image and a bunch of other things. And so we see now that the service endpoint is available, and we're just waiting for this to deploy. And in fact, we can come over here and look in the Google Cloud Console. So if I come over and look in the Kubernetes clusters, let's look at the workloads. Just look at our cluster. Maybe we're not deploying into this one. Let me just see. Maybe I'm deploying into a different cluster here. No, there we go. So yeah, so we see that WP Dev service is actually deployed here, and as well as the MariaDB instance that we specified. And so if I come here, we can see the external endpoints available for the HTTP and HTTPS versions of that service. So I'll give this a second to finish deploying. I recall this does take a little bit to deploy this particular chart. I think the WordPress Docker image takes a while to pull down and then to deploy. Oh, we got a warning that the pod failed. So one of the nice things actually is that we do get these warnings and information and feedback about failures to deploy the application. One thing I'm going to do I'll just hit cancel here. So one thing we can do is if we're failing to deploy one of these things, possibly because we don't have enough room in our cluster or something like that, let me just Control C and we'll see what happened. Looks like we were the instance was not able to deploy. Let me actually just do one thing. I may have too much stuff in my cluster, and so we may be not able to schedule the deployment of this. So let's do the config map rollout, and I'll just do a Pulumi destroy here to remove the resources that I was just deploying. Okay, so now we've got that rolled out. Let me make sure the other one is deployed as well. Which one was that? Guestbook. Okay, nothing to deploy there. So now I'll come back and we'll look at our Helm chart. So the first thing we'll do is we'll just do a Pulumi refresh to make sure that we capture any state that was in the cluster and make sure that that's adopted into our current state. So Pulumi refresh will actually go out to the cluster, make sure that we've updated ourselves with the information from the cluster. And then we can run Pulumi update to try and continue to do the update from the state that the cluster actually is in. And so we'll see here, it'll tell us, oops, right. Looks like we hit a bug there. Let me just try Pulumi destroy, and we'll start this thing again now that we've got some room in the cluster. No, it's not going to work either. All right, let me just create a new stack. We'll config set that as well. And we'll just do a quick Pulumi update. Actually, that probably won't work either because we have all the resources deployed from the last one. All right, well, we could here go and sort of debug what's going on inside this particular cluster and this particular service, but we have used up quite a bit of the time today, so I'll just kind of skip that step. We could stand up a new stack, we could tear down the old one using Pulumi, and we could also go in and use the console to understand kind of what the detailed status of this is inside the cluster. So that was a quick tour of kind of how we can use Pulumi to do Kubernetes deployments. You'll see there's a bunch of examples that we didn't cover here on other things. There's a very large example of using Kubernetes for a quite complex application, the sock shop sample application. It's also kind of an example of deploying Jenkins. This is sort of taking one of the Helm charts for Jenkins, showing what a full application, including stateful sets, looks like using Pulumi. And some other simpler ones around just exposing a deployment to the internet. And so these are some simple examples. We also have an interesting example, some examples of using AKS to use Azure Kubernetes Service and to use EKS. And so I'll just quickly show that EKS example just because it's interesting. We might come back and look at this in the future. With Pulumi, we can, in sort of one command, deploy an EKS cluster on AWS. And then we can combine that with deploying Kubernetes resources into that EKS cluster. And so just like we saw in all the previous examples today, we can easily deploy Kubernetes resources. But we can also do things like stand up an EKS cluster plus deploy Kubernetes resources into it to get a full end-to-end application stood up in one Pulumi update and managed using one command. And so using this EKS, Pulumi EKS library, we'll see that it's just as simple as kind of standing up a new EKS cluster. And this is something we'll have more to talk about kind of in future sessions, but it's a really nice thing to combine with the fundamental support for Kubernetes. Okay, so with that, I'll finish up for today. As a reminder, you can get started with Pulumi at pulumi.com or at pulumi.io. You can join us on our Slack channel and the link up here. You can come and check out the GitHub repositories for all the different components of Pulumi, which are open source. And of course, you can use Pulumi today for doing Kubernetes deployments, for doing raw infrastructure on AWS or Azure or GCP, and for doing kind of higher level container and serverless application development. Check it out today and join us on Slack and in the future for other episodes of Pulumi TV. Thanks a lot for joining. We'll see you again next week.